Hi guys, welcome to the FAIR test experiment. We're going to do this experiment in class. So what we're going to do is we're going to fill out some of the parts of the lab sheet that you're supposed to do before you start experimenting at home before we come to class. So a FAIR test is really about learning how to design an experiment that does a good job. So if you read this little intro, it says, we all know that scientists perform experiments, but are all experiments fair? In other words, is it possible for an experiment to be so poorly conducted that you can't trust the results? If so, what guidelines can we use to ensure our experiments are fair? So the objective of this lab is to investigate how to design a fair or valid experiment. So a good experiment is going to start with a question. So in order to do this, here's the question I'm going to pose to you. It's underlined in the middle here. Which will spread out faster? A drop of dye in warm water or a drop of dye in cold water? And I have the experiment set up and ready to go. So what spreads faster? Dye in hot water or dye in cold water? And you can see I have green dye in this container and blue dye, it's just food coloring, in this container. And then what I have is hot water over here. Put that back there. And cold water over here. And you can see the ice in my cold water, big giant cube cylinders of ice. And my hot water came out of a coffee maker, so I know it's hot. And what I'm going to do is I'm actually going to add food coloring to both, like so. And I'm going to wait and see which one spreads out faster. Very simple experiment, right? Already I can see that the hot seems to be a little more spread out than the cold. I did put the cold in a second or two later than the hot though, so that's not entirely fair. But let's pretend that I hit them at the same time. So far it seems like the hot water spreading out faster, right? I mean, it's not completely spread, that hot water. I can still see little bits of whiteness at the top, but it's way more spread out than the cold water. So my question to you is, pause the tutorial and answer this question. Try and do it sort of on a piece of loose leaf or somewhere where you can actually write it down, because I want you to think about it. Do you feel that you now know the answer to the question, what spreads faster, hot water or cold water? Or do you feel that the experiment has problems with it that make you not sure? Pause the tutorial and really think about that and try and write out your thoughts, because it's not just yes I think I know and no I don't. It's why, support your answer, and then come back and watch the rest. Okay, I hope that you paused and thought about this, right? And I also hope that you noticed that there are a lot of problems with this experiment. This experiment is not what I would call a fair test. Think about the parts of an experiment that we discussed, right? In a good experiment, you have to have certain things. And one of the things you need is constants. I have a control group and an experimental group. I have hot water and cold water. I'm comparing them to each other. I could call either one of them my control group or my experimental group. So I'm comparing the two things to each other, but I'm changing a whole bunch of things at once. So what I want to know is whether or not the temperature of the water changes the speed at which the dye spreads. That's what I want to know. However, at the same time that I've changed the temperature of the water by making this one on this side cold and this one on this side hot, at the same time that I did that, I also changed a bunch of other things. I've got this hot water in a flask and the cold in a beaker. Maybe the difference in how it spreads has to do with the shape of the container. I also don't have the same amount of water in both. I've got about 150 in the cold, about 250 in the cold, but only 150 in the hot. Maybe the reason the hot spread out faster was because there was less water. Or, it sounds crazy, but maybe it has to do with the dye color. Maybe green dye spreads faster. Maybe it's thinner. Or maybe it's the ice in this cold water that's slowing down the spread of the water, of the dye. So you see how I didn't keep all my variables constant that I should have? When I ran this experiment, I should have either done it both of them in flasks or both of them in beakers. I should have used the same amount of water in both. I should be using the same color dye. And instead of making my cold water cold by putting ice directly in it, I should probably use what we call a water bath. I should probably submerge my cold water in a bath of cold water, or put it in the fridge or something like that to make it cold, because adding that ice is messing things up. So I can't really tell from this experiment whether hot water or cold water spreads out dye faster. And that's not a fair test, and therefore this is not a valid experiment. It's good that it has a control and an experimental group. That helps because I can compare the hot to the cold, but because I didn't treat them the same way, the experiment is basically ruined. There's another problem here, and this is what we call a source of error. Notice how the hot and the cold water are placed directly next to one another. In your experience, if you put something hot next to something cold, a few minutes later, what will have happened? That's right, the temperatures will have equalized, right? So as this experiment is going on, my hot water and cold water are becoming warm water, so that the two things are becoming close together in temperature. So that's not helpful, right? That's what we call experimental error, where some design in the way that I'm testing my question is just a bad idea. You know, another thing that goes wrong sometimes with this experiment, people will shake the table, or they'll shake one of their containers, they'll put it down or something. Or you might have noticed when I put the dye in, you might have noticed that to put the dye in, I have to choose a height from which to squeeze. And depending how high up I am when I do that, I might get different amounts of force putting the dye in, right? And it's also hard to judge how much dye you've put in. So all of those things are what we call sources of error in the experiment. Those are things that make the experiment, hard to conduct. So designing a fair test is actually quite difficult. And that's what you're going to spend all period doing when you come to class. What I want you to do now on your lab sheets, I'll put this back up, is come up with a hypothesis. If you're like most people, you already have a guess as to what you think is going to happen. Keep in mind the test I ran is not a fair test, so you can't base your decision on what happened there. What do you think? Do you think it's hot water or cold water that's going to spread the dye out faster? Remember, you need a rationale. A rationale explains why you think that. Then, so you're going to do that on the bottom of this page, down here, hypothesis and rationale. Then, the next page, you're going to identify the parts of the experiment. So you've got independent and dependent variable. What are they? What constants do you think you need? What do you think your control and experimental group are? Tell me how many different times you want to do this experiment, because doing an experiment once is never enough. You need multiple trials before you can start to trust your results. List for me any safety precautions you're going to need to take as we work with this equipment. And then after that, the next page are the procedures. In a numbered list, you're just going to list for me the steps you want to take. Do it in pencil, because when you get with your group on Monday, you might change your mind. And I want you to be able to do that easily. I want you to be able to erase easily. So you're just filling out through the procedures, and then you're going to come to class, and you're going to actually compare the procedures that you wrote to those of the other people who are in your group, and you guys will pick what procedure you want to follow, or if you want to come up with a new one. You guys will run the experiment, and you're going to create what we call a poster presentation, where you explain the experiment that you ran and show the data to the class. And I'll teach you how to do that on Monday. Okay, see you guys in class.